The next important is the microcontroller and microprocessor. Quick comparison. What is there? Like, let's summarize the major differences. Then we'll go row by row. Okay. This is a feature. This is a microcontroller and microprocessor. How it is. Primary purpose. Microcontroller are generally designed for the control-oriented applications. Okay. But a microprocessor are generally designed around high-performance computing. Then coming to the CPU, like microcontroller integrated with the microcontroller unit system. This is a processor. This is a processor centric. Microprocessor systems often rely more heavily on the additional systems resource. Then coming to the memory, usually integrated flash, RAM, everything as we discussed before, right? But here microprocessor things often external or system level. Peripherals, then coming to the peripherals related, many are integrated, but here oftenly will externally we need to integrate it. Then coming to the power, this the power will take the less power because all will be integrated in the single chip, so it will take less power. Then this coming to the microprocessor, we connected high power because we connected externals, right? External modules. Real-time controlling, it is a external excellent fit, but it is a possible and architecture dependence. OS related, like this is the bare metal RTOS common, but here full OS common. Typical use, uh, typically used like ECUs, IoT applications, but in coming to the power microprocessors, PCs, servers, advanced systems will use it. Microcontrollers are commonly used for the real-time embedded controller, but microprocessor systems oftenly will rely the more heavily and additional system resource. Microprocessors and SOCs like system on chips are commonly used for when we need higher computing performance or rich operating systems. Then coming difference microcontroller, microprocessor and SOC. Microcontroller having the CPU. This is a one more understanding about the SOC also. Then coming to the microcontroller, it stands for the microcontroller units. MCU means it's having the CPU, memory, and peripherals are highly integrated for the embedded controller. Okay, this is dedicated for the embedded controllers. Then examples STM32, RH 850, Renesas 850. Then coming to the MPU means microprocessor unit. It is processing centric and typically works with the additional system resource. Okay, it's having the Intel Core, AMD, Cortex. Yeah. Then coming to the SOC, SOC means system on chip. Uh, a modern SOC can integrate CPU cores, GPU, memory controllers, connectivity, and specialized hardware. For example, our phones, its phones having the microprocessor and memory, everything will be integrated in our. If we take the mobile as the example, advanced computer, complex embedded platforms. Okay, this is why modern computer devices doesn't always fit perfectly into a simple microcontroller versus microprocessor comparison. Then now you will get some doubt. Which one should you we need to choose? So which one should you choose? Next, choose a microcontroller when you need sensor reading, actuator controller, and GPIO, timer, scan, lean, low power, and predictable control behavior. Like if your application needs this kind of things, MCU microcontroller is often a good choice. Then coming to the microprocessor or SoC, if you need high computer performance, rich graphics, large memory, complex applications, or a full operating systems, and microprocessors or SoC may be more suitable. Example, example here I given the example. If you take the washing machine controller, the microcontroller will be suitable. But automotive control unit, control ECs, automotive control ETs, then mostly microcontrollers will commonly use. Okay. Then any Linux based infotainment, then microprocessor or SoC will use. Like high performance vision or graphics, then we'll use the microprocessor or SoC. Commonly we'll use. Okay, now we understand, right, what is the difference between the microcontroller and microprocessors.